now we are officially...
Yeah, I saw the message top of the screen.
So are you a Game of Thrones fan, Satareh?
I'm sorry?
Are you a Game of Thrones watcher?
Yeah, no, unfortunately not. So I haven't been following, but I saw that there were a lot of comments about the final season. A lot of people were unhappy.
A lot of people were unhappy. The writers kind of got dragged through the mud a bit, but there is, funny enough, on change.org, there's this petition that has now been signed by over 1 million people that is petitioning HBO to get new writers and redo season 8.
Oh my God, that's kind of extreme.
It is definitely extreme. It would be so funny if it happened though. People would love HBO if they did it.
Okay. Yeah, I saw one of the comments. They're saying that at least I'm not disappointed that the show is over because I saw the very bad ending.
Yeah. They didn't do it justice. Hello, welcome everybody. We're gonna give people a minute or two because you all are a bit early to join, and then we'll get started. We'll avoid any Game of Thrones spoilers just in case. Don't worry. Yesterday in here in New York, the weather was incredible. It was like 80 degrees for the first time in a year.
Oh yeah, same here. And it's funny that the very next day is like, what, 60 or something today?
Yeah, and today is a little colder, right? Because you're in New Jersey, right? So the same exact climate as New York, obviously.
Yeah.
That's awesome. Does Oracle, so is there like a big office in New Jersey or?
No, not really. There is one which is kind of far from me, so I don't go to office. Yeah. But it's not a very big office, yeah.
And then there's one in like Manhattan, I assume?
Yeah.
Cool. That's cool. All right, we're gonna give it 30 more seconds, then we're gonna get going. So just hang tight, team. It's nice to have you all here. Is it the beach behind you, Satareh?
Yes, like a bottle in a beach. You can see part of it, yeah.
Very relaxing.
Yeah.
It's very relaxing webinar background. All right, we're 1 minute past the hour. Let us begin. Hello and welcome to this edition of an AI for Retail webinar. My name is Michael Weiss. I am with the AI for Retail team. We have our conference upcoming on June 24th and 25th here in New York City, which I think, Satareh, you're going to be attending.
Yeah.
So you can meet her there. And so today we are lucky enough to have Satareh join us from Oracle for her discussion on whether or not to build or buy your AI retail platform. Now, the one housekeeping note I'll mention is you should notice a Q&A button on the toolbar of your Zoom interface. So if you click that, you can submit a question at any time throughout the webinar, and Satareh will be sure to answer it either during or at the end. So feel free to go crazy with questions. Questions are great. And now, without any further ado, I will kick it off to Satareh, and she'll give a better self-introduction and then jump into the presentation. Thank you for being here, Satareh.
Thank you, Michael. All right, I'm sharing my screen. I hope everyone can see it.
Looks good.
Okay. Okay, good afternoon, everyone, or maybe good morning, depending on where in the world you are. My name is Satareh Borjian, and I'm from Oracle Retail. I'm going to talk about this question that has become more and more popular and like a dilemma for the retailer, whether retailers should buy or build the AI and data science platform for their business. A little bit about myself. I'm a data scientist at Oracle, and over the past few years, my job has been to develop products that are focused on machine learning, optimization, and AI-enabled solution for retailers. I have worked on the complete life cycle of the product, from modeling and finding the right algorithms to the design and development. And I've seen a lot of challenges in this life cycle, both in developing the product and when it's being implemented by the retailer. So some of the stuff that I'm going to talk about is based on my experience over these past few years. I have also worked with other teams in other business units of the Oracle, food and beverage and hotels. And while the type of challenges are different, there's always these challenges when operationalizing the data science solutions. A little bit more about my background is that I kind of came an odd route to end up here working in retail. I did my undergrad in mechanical engineering, and then I did an MBA, and then an operations research, which is actually my true passion. In mechanical engineering, I worked on optimizing the car transmission systems, and I found the retail to be just as complex, maybe even more complex than a car transmission systems. So it's funny that I ended up from that area to retail, but it's all good. I really like it in this industry. Okay, so one of the main reasons that this question has become more of a dilemma for retailer and has become more talked about recently is because of the trend in the market about what retailers are investing in. There has been an increasing trend to invest in different data science solutions. And if you look at the areas that retailers are interested in, these are all highly complex areas. Price optimization, inventory optimization, the tracking analytics of shopper. So these are type of problems that really requires an advanced solution. So when retailers face these kind of problems, it's natural to think about whether I should build something or buy something. Let's look at the AI and data-driven solutions. Let's look what the different components, different moving parts are. In any kind of solution for that, and this is not just specific to retail, you can think of it in any industry, there is a data science layer. And there are different components in this layer, and the center of all these components is obviously data. Everything starts with this data cleansing and pre-processing. There are several steps to enable this process. There are checks for sufficiency of the data, quality of the data. You all know that in models, machine learning optimization, we have this saying that says garbage in, garbage out. So the key part, the key first step is to make sure that we have right data and clean data being fed into the subsequent steps. There are steps for removing and identifying and then removing outliers and anomalies, and of course anonymization to make sure that data is secure, and aggregation. So depending on the type of the problem, the use case that a retailer is looking at, they may want to look at the data at small incremental times. For example, for clickstream data, you are interested to see at each second, each minute, what the shopper is doing. But for other certain problems, maybe just the aggregate sales at weekly level, at chain level is sufficient. So all these steps prepare the data to be used by the rest of the process, by the rest of the components, which eventually produces something that is consumable by the retailer. The two main data science components is machine learning and optimization. In the machine learning component, there is this process for building the model. Depending on the model, there are parameters that needs to be set by the data scientist, or there are algorithms to tune the parameters. Then there's this decision about what algorithm should be used to estimate the model. And of course, the training data, what should be fed into the model, and what are the measures that the model should be tested against. So you can see that there is this iterative process of building, testing, and tuning. And this is something that sometimes is more of an art that is done by the data scientist than an automated process. Similarly, in the optimization, there are models that need to be built two key components or ingredients of the model or the objective. What are you trying to optimize? Are you trying to get the most revenue over the next season, or the next quarter, or do you want to maximize your sell-through? Or maybe it's a combination of both. Actually, I'm going to talk about that in more detail in few slides. And then there are constraints, which are a representation of your business requirements. And the model is built based on these two. There's the formulation for the optimization problem, and similar to machine learning models, you need certain algorithms depending on the type of the problem to solve the optimization problem. Some algorithms are more performant, but produce less or suboptimal results. Those are the heuristics. Or you can use exact algorithms which are computationally expensive. And then all these, they become consumable by the user, by the retailer, and by your business only if you can visualize and analyze and look at the data in a meaningful manner. So the final step in this process is to post-process the output of these models to generate reports, graphs, visuals, depending on the type of user who is looking at the output, and then finally use this in any downstream apps or systems which is supposed to consume this data. Now, you can see that data science layer is complex enough by itself. In a prepackaged solution, in a software solution, there's another layer, which is the application layer. To enable user to use all this data and see the flow of the data from input to output to all these reports, there needs to be a workflow in place. And I will talk about that in more detail when I'm talking about an example. And of course, to facilitate this workflow, there is a user interface, which you have seen in all different software applications. And then, of course, there are other considerations in software development. There needs to be exception management rules to make sure that all unforeseen and rare use cases are being handled properly, and the security of the code and the data, and all those small details about software development. So this application layer sits on top of the data science layer, and these two together makes the software solution. So it's always easier to put things into context. Let's talk about one of the examples that most retailers are faced by. This is the promotion and markdown planning problem. And the key questions that retailers would want to answer is that, when should I promote or markdown? Which items? How deep? Should I do like 10%, 20%? And these decisions are not like made. There's not one set of decisions for the entire business. They can vary from location to location or from country to country. And then one step beyond that is what should be the personalized offers. I want to personalize my promotion and make sure that I'm targeting the right customer or right customer segments. What should be the targeted offers and who should I target? So these are the key questions in this one of the problems that retailers face in their business. Just looking at this picture to show what a typical promotion planning policy could look like is that we have one item here with a life cycle of 12 weeks. And then, for example, here the promotion policy suggested by the system is to have 2 promotions at week 4, week 7. There's a sale at week 2, and towards the end of life cycle, there are 2 weeks for markdown. And there is also targeted offer pushed to the device of certain customer segments aligned with the promotion timeline at week 4 and week 7. So this is an example of the solution or the optimal policy that retailer would get from a prepackaged software solution for promotion planning. I'm sure by now you're convinced that these problems are very complex, but just to draw the picture and complete the picture, if you think about different dimensions in this problem, there is the number of prices that the retailer can select among, and there is the number of weeks, can select 10, 15 is a typical life cycle for fashion items. Then there are hundreds of items. It can vary from smaller retailer to larger retailer. And then if you add also the customer dimension to this, there's just huge number of decisions that need to be made. And this is not something that can be done manually or by Excel spreadsheets. It requires advanced optimization and machine learning techniques. Excuse me. So there are prepackaged solutions for this problem. One of them offered by Oracle, and there are plenty of other firms, including startups, that have solutions for this kind of problem. If you look at the data science layer for this specific problem, there are 4 modules inside the data science layer. There is the forecasting module, which forecasts the demand and return for different items at different locations and potentially for different customer segments. Then there's a customer segmentation module, which actually creates the segments of customers based on different data, different sources of data. There is a recommendation system which generates the targeted offer that we talked about earlier. And then on top of all these sits the optimization module, which optimizes or maximizes the revenue or any other objective. Here I'm taking revenue as an example, by taking into account the forecast, the segments, and the recommendation. And then, as usual, the center of all this is the data. In this case, for example, the input data includes the historical transactions, attributes of the products and customers, competitor price, and there could be other sources of data too. Now, if you think about the application layer in this example, we talked about workflow that enables user to consume all this data. In this example, it starts with the system or machine generating the optimal promotion plan and targeted offers, and this is done inside the data science layer. Then no user is going to blindly trust the machine, and that's wise. So the workflow allows user to review this plan, to modify them if needed, for example, override a certain type of promotion or offer, and approve them. For example, this can be done by a business analyst user. And then the final step in the workflow is to push these approved plans for execution to downstream apps, for example, the marketing system or price management system, or push them to other users for further review. And to facilitate that, there's a user interface that allows user to navigate between different screens, look at the numbers, create charts, look at the charts, and do all these approval, override, and review. So for the rest of this talk, I'm going to focus on the data science layer, because workflow and user interface is something that comes with the prepackaged solutions, and there's not much opportunity, and it's not simple to customize that, and there may not be even necessary. So I'm going to focus on the data science layer. I would like to talk about 4 areas that retailer can benefit from customization and can benefit from having some customized solution in those areas. So these 4 areas is the models and algorithms, the alternative models and algorithms that retailer can use, whether they can enhance the existing machine learning models, the ones that already exist in the prepackaged solution, if they can use other sources of data, and finally the custom reports and visualization. Let's talk about the alternative models and algorithms first. We saw that the two components in the data science layer, machine learning and optimization. These are the two main components that actually produces the optimal plan and all the forecasts. It is not uncommon for prepackaged solution to implement and use the easier to implement and easier to maintain version of the algorithms. And there's a good reason behind that. First, like I mentioned, it's easier to implement and maintain, and also most of the time they offer adequate efficiency and accuracy. So if we think about different machine learning models, there are three broad categories. Forecasting models and algorithms which are used, for example, for demand forecasting or return forecasting. Then there is classification and clustering that is used, for example, for customer segmentation or store clustering, and there is recommendation system. What you see in practice in most packages, the methods that are used for forecasting are the time series methods and sometimes simpler methods like historical average. I've also seen linear models too, but it is not very common to use more complex methods like ensembles and neural networks. And while these methods in some cases can better model like external factors, for example, when there is factors like weather, like the interaction between customers, when there is social data, they are not easy to implement and they are not easy to visualize and interpret. So most of the prepackaged solutions, they implement the easier or the simpler algorithms. Similarly, in the classification and clustering, the typical methods like decision tree or k-mean, they are computationally fast and they are easy to implement, but there can be use cases where the data is too noisy or there are some nonlinearities in the data which makes other more advanced methods more suitable. In the recommendation systems, one of the popular methods is the association rule mining, which is common and popular because it's easy to implement, and also it doesn't require customer or product attribute. So it can be implemented just by having the aggregate sales data, but there are more advanced methods that can be used to generate more personalized recommendation, and are able to capture the similarities between items and products. So there's this spectrum of models and algorithms, and most of the time in prepackaged solutions, the ones at the top are being used. Similar thing can happen in optimization. In optimization, if you think about the three or the main components, there are three of them. There's the objective, what you want to optimize. There are constraints, what are the business requirements, and there's the decision variable, what is the optimal policy that you should execute. So most of the time, the constraints are dictated by your business requirements, and decision variables are clear because that's the policy that you want to optimize. But picking the right objective is the key for the retailer. What we have seen in practice is that some retailers find it useful to look at a combination of objectives and find the right balance between two metrics. For example, the sell-through and profit. Using a multi-objective function of these two may be a better option for some retailers depending on the business. Or we have seen that some retailers are find it more practical to use more complex metrics rather than the revenue. So this is one area that the retailer may find opportunity and benefit in customizing the model. Optimization algorithms are also customizable, but this is less flexible because you can use different type of algorithms depending on the type of the problem. Exact algorithms usually require commercial solvers, so you have to pay for licensing fee, or it requires a lot of coding effort and testing. So this is a less flexible area to customize and tweak what is already offered in the prepackaged, but still there is possibility for that. Okay. So we talked about exploring alternative models, but there are cases that you can just use the same machine learning models that is being offered in the prepackaged solution, but enhance it by changing something that inside the model. Looking at the machine learning pipeline, everything starts with data preparation, and then the next key step is to select or create the features that should be fed into the model. And then the subsequent steps are to choose the right algorithm, set the parameters, test and tune, as we talked about. In a prepackaged software, it is expected, and it makes sense, that all these steps are explored and decided by the vendor. And also, most of them are automated, because that's just the nature of a prepackaged solution. So for example, if you think about the second step, which is feature engineering, that's the key question of which factors, which features should I include in the model for forecasting or any type of classification or clustering. Because it has to be automated in a prepackaged solution, most of the time simpler techniques are being used. For example, in the promotion planning software, all the features could be used to generate the segments, or it could be the case that some simpler technique like filtering techniques, which looks at the correlation between different features and the outcome variable, are employed to select the features. So bottom line is that there is not much flexibility and art into it, because it is an automated process. But sometimes it's beneficial, and there's opportunity to create new features, to combine features, to simplify the model, or to also gain better predictions, more accuracy. For example, one could use the light color or dark color instead of using the actual colors to build a model. So this is an area that data scientists could actually play with the model and see if creating these new features can benefit them by simplifying the model, which can decrease the time, the estimation time. It can make it more performant, or it can increase the accuracy. We keep talking about data, and obviously the data is the main ingredient in all these solutions, and it's actually something that give retailers competitive advantage over other firms. In most prepackaged software solutions, there are limited sources of data that are being used, and if there are solutions that actually take or use a lot of different sources of external data, they can be very pricey for the retailer. So it can happen that you have an off-the-shelf solution that meets most of your needs, but you have access to an external data source from first party or third party, and by using that data inside the solution, inside the models, you can actually enhance your model. For example, I mentioned that the customer segmentation module in the promotion planning uses data like demographic, product attributes, and customer attributes to segment the customers. But in the case that the retailer has access to, for example, a social network of their customers, it can actually be benefit them to create segments based on the social data and have these social based segments. And by comparing these segments with the original segments, they can see whether there's any benefit to that or not. So this is an opportunity for retailer to use additional sources of data to enhance their models. And finally, we talked about this data science layer. The last step is reports and visualization, which is what enables users to actually understand what's going on in the process from getting input data to the output data, and also understand the output of the models and optimization. Most of these software applications, they don't have powerful tools for visualization, and that is understandable because they are not meant to be used as reporting tools. So what happens in reality is that oftentimes users extract the data from the application and transfer that to other tools like Excel spreadsheet or Tableau or similar tools to be able to analyze the data and create charts, graphs, and similar objects. But what would be more efficient is that if user can generate those and analyze the data within the application. The main advantage of this approach is that there is easy and secure access to all input and output data. Data never needs to leave the application, which is nice. And also, if there are tools and packages that are embedded in the software application, user can use those, the open source tools. Okay, so some of the examples of reports or visualization that I've seen people want to do, like the network of customers, or looking at the different clusters to find outliers. So these are just some of the examples that are created using R and Python packages. Okay. So nothing comes free, right? If there's all these nice things about customization, why not build from scratch? Because there's costs and risks to that. The main cost for custom solutions, building something from scratch, is the development and QA cost. If you think about the promotion planning, which is a sophisticated solution, it takes at least 1 year of a team of about 10 people, including UI designer, UI developer, database developer, quality assurance, and most importantly, data scientists, to design this solution, build the solution, and run it through QA process. So that's 1 year of a team of like at least 10 people that is spending time on building this solution. And there's also the cost of tools and infrastructure for coding, for version controlling. Another example that I mentioned earlier is about the optimization solver. A lot of time, commercial solvers are most efficient to use, and there's licensing fee associated with that. And thinking about the risks, just like any other software development project, it takes time for the solution to be ready, and the time is not always on schedule. So this time that it takes for your solution to be built can be a risk for the business. And sometimes, because you want to have something ready to use as soon as possible, retailer try to go with simpler approaches or try to remove some of the QA steps, and that just translates to technology debt, meaning that later they have to come back and revisit the code or revisit the approaches and models, and that's just an additional cost. There's also the cost of or the risk of maintenance of the code, and of course the opportunity cost of the team who is working on building a solution like this. But it's not all bad. There are a lot of good things about building something in-house. You can do all customization. You can have a solution that is tailored toward your business, all these 4 areas that we talked about. And another key area is the integration. So as I mentioned, all these software solutions, they're meant to be used by other systems, like promotion planning is going to be used by marketing system or pricing management system. So this integration has to be done between the promo planning and other systems. If the architecture is different, if the data warehouse is different, and if there's not like enough commonality between both, the integration could be a hassle if you have an off-the-shelf solution. But if it's in-house, obviously you can work around integration more easily. And when you have this solution in-house, you're more agile. You don't have to be limited by the release cycle and release schedule of the vendor. If you want to add new feature, to add enhancements, it's all in your control. So these are all things about cost, risk, benefits of building something from scratch. You can see that same or similar arguments can be made for buying something off the shelf. There are all those trade-offs. What I'm proposing here is that what if you could get the best of both worlds? So you have a prepackaged software with all these built-in functionalities, models, algorithms, and most importantly, the application layer, which gives you the workflow, the UI, and the nice and secure application. And then you also get a platform with access to the data and open source tools and algorithms to use for any type of customization that you want to do in one of the 4 areas that we talked about. So this is the main idea behind a hybrid software solution. And let me talk about a little bit how the architecture works here. So we have the prepackaged solution with all the built-in models, algorithms, tools, workflow, UI, and so on and so forth. And of course, data is a main part of this solution. Then there is the data science platform that provides programming languages like R and Python. There is Notebook, which is a web-based code editor. It also offers libraries and packages for machine learning, for visualization. There are solvers for optimization, and there's also data storage and workspace. So these are all different capabilities within the data science platform. Then the way that these two connect is that the data can flow from the prepackaged solution into the data science platform. Also, if you have external sources of data, it can be fed into the data science platform. Now, with combination of this data and all the nice capabilities in the data science platform, you can implement and test new forecasting or machine learning or optimization models. You can leverage other sources of data and also create customized visuals and reports. And if there's anything good that comes out of this step, there's something that you like better than what is already being offered in the prepackaged solution, you can feed that back into the prepackaged solution and merge it with the existing functionalities. So let's look at an example. This is the example of attribute extraction from images. In the targeted promotion planning, one of the required data is the attributes of the products. Now, this has to either be provided by the retailer, or in more sophisticated and advanced solution, the software can extract the attributes from description strings. Now, suppose that retailer has product images and they believe that they can get more and better attributes from the images, but this capability does not exist in the promotion planning software. So what the data scientist can do is to load the product images into the science platform, and science platform has visibility to the data in the prepackaged solution, so it can see and use the existing product attributes. Now, the data scientist would build a machine learning model. For example, there are packages in Python for that, to extract the attributes from images, and to actually build the model, test it, and tune it. They can use code editor or SQL command or any other available tool. And then lastly, they compare the output with the existing attributes in the software, in the prepackaged software. And if this is something that they want to use, or actually they can even merge it with the existing attributes, this goes back to the targeted promotion planning application. So this is one example of enhancing your model, or using different model, and also using external data within the data science platform in combination with the prepackaged solution. Okay. So I talked about all these nice things about a hybrid solution. It's flexible because it allows you to use the algorithms, state-of-the-art algorithms that data science is already adept at. And then it's reproducible because there are shared workspace data science can use and reuse each other's codes. And it's also scalable. You can add more data, build new models, use more efficient algorithms. But most importantly, in my experience, is that it's productive because if you remember that in the data science layer, everything starts with preparing the data for the rest of the process. So there's this huge effort and time-consuming task of data cleaning, data preparation. And when you use the hybrid solution, you already have access to the data that has been cleaned and pre-processed and is sitting nicely there in the prepackaged solution. So it saves data scientists the time and effort in running the machine learning pipeline, and instead of spending time and effort on the data preparation, they can focus on the later steps in the pipeline. To wrap up, I want to show you this kind of spectrum that there is buy off the shelf on the left, build from scratch on the right, and there's benefits to each of them. And then there's hybrid solution that kind of allows you to get the best of both. And now the question is that, is there a sweet spot for you as a retailer? The short answer is that there's no one-size-fits-all solution. So it's not like that for every retailer, hybrid solution is the best. I think some of the key questions that you should ask when deciding whether to build, buy, or look for a hybrid solution is that are there prepackaged software that meets most of your needs? For example, for promotion planning, if you find something that meets most of the business requirements that you have, it's a nice start. Now, do you see use cases or opportunities for customizing that solution? And most importantly, do you have a data science team? So, Michael, actually, I want to ask this question from the audience. How many of you have data science in-house?
The poll is launched.
I'm also going to answer for Oracle, obviously, the answer. But I mean, it's not from like a retailer standpoint, but I'm just going to do it. Oh, yeah, it says that the host can't vote. Okay.
All right, 5 more seconds to get your votes in. 5, 4, 3, 2, 1, 0.5, 0. Thank you for playing. End poll. And I'm going to share the results. So we have 45% said yes, and 45% said no. And then the remainder said not sure.
Okay.
So it's fairly even split between the yeses and nos.
Okay. Yeah, so actually 45%, that's a fairly large percentage. So for those 45%, if you have a data science team and if you can find a prepackaged solution that works for you for the most part, the hybrid solution could be a very nice fit and allows you to get the best of both worlds. And with that, I'm going to wrap up. And if there is any questions, I'm happy to answer.
That was awesome. Thanks, Satareh. I think that answered the theme of build versus buy perfectly. And I guess it was sort of a clever answer with hybrid, but I think that makes a lot of sense. All right, so if anyone has a question, you can either type it in or raise your hand, and I can enable your audio to work. So we'll hang for 30 seconds as any questions are formulated before we depart. So the future is hybrid, huh?
Yeah, I think at least for some retailers, it has to be.
Yeah, I mean, it makes a ton of sense. It makes a ton of sense. And I guess, right, and that's probably agnostic as far as industry, the idea of hybrid solutions.
Yes, but I guess the retail industry is more mature in that sense. So I think if we ask this question of whether you have data science team in-house from maybe like hospitality or food and beverage, the percentage would be smaller. So I would say retail is more mature in that sense.
Got it. That's interesting. That's interesting. Yeah, we're seeing, I mean, with our AI for Retail conference, in a month, we're definitely seeing most major retailers attending, and most of them have at least some data science team. They don't all have hundreds of data scientists, but some do. But yeah, so most big retailers definitely have a data science team. I guess, well, maybe 45% though, who knows? All right, so we're not seeing any questions. So speak now or forever hold your peace. Satareh, I thank you very much for joining us. I'll meet you in person on June 24th and 25th at AI for Retail. Hopefully some of you will be there as well. And I wish everyone good luck in their data science efforts. And Satareh, any final words?
No, thank you for the opportunity. Looking forward to meet you in June.
Awesome. Godspeed, everybody. Thank you for joining. Bye.